Hi, I'm Richard, and in today's tutorial we'll be looking at the reaction diffusion algorithm to create weird effects like this. So let's get started. Hi, and thanks for watching. And before I get started, there's a couple of things I'd like to say. Number one is an apology for not producing a video, I think, for 2 weeks now. I have managed to get a job, so thank you very much. That's good news. I guess good news for me. This is I'm earning some money, but the bad news, of course, is that I've had a lot less time to crack on with these videos. I tried. I had all sorts of problems with the treasure chest that we were doing with the animation, and I started working on this algorithm in 3D, but also had loads of problems. So the small amount of time I have had has not been going particularly well. But I've managed to get a 2D version of this, which is what you've just seen in the intro there. But which leads me on to my second point, which is that I'm afraid the speed at which it generates that, well, I don't know what you would call that organic style maze, is considerably slower. And I'm not, when I say considerably, I mean much slower. That was sped up, I think, 64 times to make it look somewhere near reasonable. Unfortunately, it's a lot slower in real life. But of course, I have gone for a 512 by 512 grid here. If you halve that size, well, quarter that size to 256 by 256, you'll see that it's a lot quicker. So let's talk about what this is. Now, as you know, I've been getting very much into dungeon algorithms recently, and I found this algorithm here that creates this organic effect, sort of trawling through Google and a little bit of YouTube as well, and it's called a reaction diffusion algorithm. And what that means, it's a lot like, for those of you that are familiar with the game of life, which is an algorithm that says a neighbour will die if it hasn't got enough adjoining neighbours. It will be born if it has exactly so many neighbours, and I think it stays as it is with any other number or something like that. There's some very generic rules, and they create these rather interesting looking patterns. Well, if you like, just to say that this is all on a grid, okay, of sort of ons and offs, so you'd have a black and a white. But what this is actually doing, this is taking it a step further, where you would have shades somewhere between 0 and 1. So 1 is completely black, and 0 would be completely white. And what you have is this rather scary looking algorithm here, but don't panic. And what this is saying is the state of this cell in the next generation is going to be this plus DA. What's DA? And then you've got this weird looking upside down triangle called a Laplace or Laplacian, I think. A and AB and A, blah, 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 blah. Right, crikey, that's a lot of stuff going on. Well, don't panic, because some of these are actually constants. So DA is 1, DB is 0.5, so you can see some of that's not too bad. K and F are also constants. So A and B are, if you like, the values within a cell. So a cell doesn't just have a 0 and a 1, it actually has two values, an A and a B. One that you start off with a value of 1. I think A is always 1 to start with, and B is always 0. And what you do is you set B to be 1 for a few of the cells in the grid, and then away it goes, and then each generation will create this. It'll kind of expand out to what you just saw. But it's still pretty scary, isn't it? But don't panic. I mean, the thing is, as I found about through experience in maths, these functions can look pretty terrifying, but actually you just break them down, and we'll see in a minute. This actually isn't too bad. All we're saying is here, do a little bit of magic around what's already there for the current A and B, and also look at the cells around you. That's what this does. Look at the cells around you to also influence your current cell. So how do we go about doing that? Well, what we're going to need to do is we're going to need to create a grid of a defined size. We can say 512 by 512. I suggest we try something smaller for testing purposes, and what we do is we put a couple of ones in there somewhere and just watch to see what happens. And what we'll do is we'll create what you call sort of the next grid, and that will contain all of the future values, and then we'll flip that back so that the next grid becomes the current grid, and then we'll redraw it, and then that goes on forever and ever and ever. A bit like the game of life. This is how the game of life works. It looks at all of the elements in a grid, and then it says, right, okay, well, this is what the new grid's going to look like. Okay, let's use the new grid, and then the new grid is used, and then the next one goes on and on and on. So and that's what's happening here. it wouldn't take a genius to work out that 512 by 512 is a very large number of iterations. So it's going to look at each cell. So 512 cells by 512 cells, which comes to, quickly, anyone? Let's just get the calculator out and have a look and see how many that is. I think it's pretty large, except this isn't working for me. Sorry about that. Let's try it again. 512 times 512 equals 262,144 iterations. So it's going to be looking at every single cell and doing 262,144 iterations. So you can see that if it's doing that, it's not going to be particularly fast, unfortunately. And it's redrawing that every time. But the good news is I'm getting around about 15 frames a second. So, you know, it's taking it maybe, what's that, about 50 milliseconds, something like that. I don't know, about 100. No, yeah, between sort of 40 and 50 milliseconds per iteration. So that's pretty quick. But it's, you know, to create a grid that size is it is rather slow. So we'll do something a little bit smaller to start with. Now, I should say that one of the websites you should check out, one of the YouTube channels you should check out, is this guy called Dennis Schiffman. He was what inspired me to do this. I initially wanted to try to do this in 3D. I had some issues with that, which is why we got 2D. If there's enough interest in this, I will do it in 3D in Unity. This guy here, Dennis Schiffman, I'll put Daniel Schiffman, excuse me. I will put a link to his YouTube channel in the comments. This guy is passionate about what he does. He's well worth watching. He's the sort of guy that I really enjoy watching his videos. He's a bit bonkers. You can see he's a bit of a hippie with his coding rainbow nonsense. So, but I definitely encourage you to check this guy out if you're enjoying this video. Please come back to mine, but also, you know, credit to this guy who's absolutely brilliant and does a really good job of explaining it. Alright, so with that said, let's start coding this thing out. Is there anything you need to say in terms of how this is going to run? I don't think so. Should we just crack on? Yeah, I think it's basically. One thing I was going to say was that you can change these constants to create all sorts of different effects. So we should have a good old play with that. See if we can look at some of these numbers and, you know, create weirdness like this as well. So this is going to be a bit of a fun project, particularly when it's finished. And I'm going to do something I don't usually do, which is type this out as I go. So I already apologise for all sorts of mistakes. I've got my printout from the previous one. So let's crack on with a brand new project. So I'll stop this now, and we'll start off with a new project. So let's do that. File, new project, and we'll call this. It's a 2D project, so we'll click on 2D. And we'll call this reaction. Oh, look at that. Reaction diffuse tutorial. I've already done this once, so but that should be okay. So 2D, make sure 2D is clicked and click create project. Let's save what I've done there. I don't know what I did there, but let's save it and open Unity again. Just make sure I'm recording while that's going on. Yes, we are. Thank you. Right, here we are. And here we've got ourselves a 2D screen. Now, I don't do a lot of 2D work. Most of my stuff's been done in 3D. There's some good tutorials on, obviously, the Unity website about 2D, but you can tell that I cannot rotate around the Z-axis, the Y-axis. I don't know. I'm very much in 2D space now, very flat, what you might call orthographic view. All right. What I did as well, by the way, was I created a new aspect of 1024 by 1024 here. Alright, it doesn't have to be that large. I'll just show you how I did that. If you click on plus here, you can just add label. You can call the label what you like, you can call it Fred if you like, but set the width and height to be 1024 by 1024. So basically a square, and this is it's a power of 2. I won't go into. Hopefully that's not a big issue for you, and you can see why I might have done that. So what we'll do is we'll create a texture. We'll create a plane. Excuse me, 3D object, which is weird. It's plane. All right, and you can see it there. And what we'll do is we will reset these values here to zeros, and I think it's -90 there. And that's gone rather well. I can't believe it's exactly the same size as that camera. Did it know what I was going to do? If we click on the main camera here, you can see it's actually you can actually expand this and shrink it out. Right, so this is the camera, and it's looking straight down at it, and that's worked for me straight away. And I don't know why. I didn't think that was going to work. So the size is 5. The plane maybe is of size 5. So we're off to a really good start. We do need to add a texture to this, a material to it, and we'll be automatically on the fly adjusting the texture. So let's get a let's create a material, and we'll just call this base material, something like that. It doesn't really matter. It doesn't really matter. But the important thing is it's going to be, I think it's unlit texture. Okay, and it's got no texture there right now, but we can. Is it that one? Hang on, let's just have a quick make sure which one it is. 1 second. I thought it was unlit color, and that's right. Yes. Now we should hopefully it'll have a renderer. It does indeed. There we go. So okay, so we're off to a good start there. So if we go back to base material here, main color, we can make it white or whatever, but it doesn't really matter for now. Let's just drag that in. Okay, the unlit bit's important because we don't want any lights to affect this right now. We're not interested in lighting or shadow. We just want an unlit bland texture like that. We can change it to whatever colour. It doesn't really matter because we'll be overwriting this in our code. Now, that's our base scene set up, if you like. That's a nice easy scene for us, isn't it? Now what we're going to do is we're going to create a grid. So we need to create a grid of 512 by 512. It doesn't matter that this is 1024 by 1024. It will scale the texture to be the right size. And in fact, I'm already a bit concerned that this actually doesn't have a texture on it, so I'm going to try a different one. Let's do that again. Unlit texture. Okay, that seems to have worked. And that's there you go. It's got a texture. It hasn't got one because we'll be creating one for it. So that's fine. So there we go. All right. So that's got its texture there. So let's start creating some objects that we're going to need for our algorithm to work. And I think the most obvious one is a cell algorithm that's got this A and B value. So let's very quickly do that. Let's create a C# script. For now, I'm not going to create a subfolder, and we'll just call this. Should we call it RD cell? So reaction diffusion cell. That seems to make some sense. So let's double click to go into MonoDevelop. 1 second. Is that big enough? I'll just go one bigger. This doesn't need to have any. Doesn't need to inherit from anything. It's just going to be a very simple A and B. Delete, and then we'll go public float A equals, I think it was 1.0f. So this is the default. And public float B equals 0f. I'm pretty sure. Let's just spin back to our thing here. It does say somewhere. There you go. So you initialize with A is 1 and B is 0. Alright. Okay, and you can see here what it's saying is just before you start, set a few of them to 1 and kick off and see what happens. But we'll do that later on. Alright, so we've got our public float A and B. Lovely. Back to here we go. That's our cell. So now we need to start thinking about creating a grid of a certain size. So let's do that now. So let's create a excuse me, it's down here. So we'll create a new C# script. This is going to do all of the work, and we'll call this a reaction diffusion. I don't know, cell generator, grid generator. Grid generator sounds too generic. I want to make it more generic than that. Let's call it reaction diffusion generator. In fact, let's call it reaction diffusion. Oh, was diffusion got 1 F or 2? That's terrible, isn't it? I can't remember. It has got 2 Fs. According to this, it has. Yes, it has got 2 Fs. You'd think I'd have done a bit of research on this first, wouldn't you? Right, okay, so we've got our cell set up. It's very simple. Why aren't you changing? Did I save you? Oh, where's... looks like I didn't, so Shift Control S, there we go, and that should go back in there. There we go, that's better, so it's nice and saved now. So let's go into this guy. This is the one that's going to do all of the work. So first things first, let's get our texture added to it. So what we'll do here is we will say we'll keep it private for now. Private texture 2D texture, and in the start function we will say texture equals new texture 2D. And actually what we'll do, let's just do that a second. We'll have here, just above it actually, public int width equals, I don't know, let's just say 512. Public int height equals 512. Alright, and we'll just do that, and then we'll just put in here width comma height. Okay, that's good. And then what we'll say is what we're going to do, by the way, is we're going to attach this to the plane itself, and this plane has a renderer here and it has a material, so we can get that information. So I think what we do is we say renderer. So the renderer for this object that we're attached to, say renderer equals get component renderer, and then renderer dot material dot main texture equals texture. Okay, so what we're doing now is we're saying use this texture here. So let's just see how that goes. If we just save that, and then what we'll do is we'll attach it to our plane, which we might rename in a minute, and we'll just set over there. Any errors? None yet. So let's just run this. I'm not expecting miracles. I'll take off maximize on play, click there. It's a good start, isn't it? And if we go over to our base material, I thought that would work. Maybe it's in here. If we click in here, you can see it's now got a texture, like magic. It's got a texture. It's a very grey looking horrible texture, but it is a texture. And now if I stop it and look at it, it's no longer there. So this is good. So we're attaching a texture to our material. Let's give it a colour and see if we can make that work. 1 second. So let's spin back to our script here, and what we'll do is we'll say, I think already I'm going to put this into a method for int x equals 0, x is less than width x plus plus. We're going to use this a lot, I think. And then for int y equals 0 semicolon y plus plus, y is less than height, y plus plus, like that. And then we'll just go into here and say texture dot set pixel x comma y, and we'll just say color. Let's just do color.yellow for now, just to prove this works. Okay, and that'll do it. But what you need to do at the bottom is just, I think you need to say texture.apply. If you don't do that, it won't actually make any differences. So let's just try that now. So now what we've done is here, we've created our texture. We're going to set all of the pixel colors to yellow, and then we're going to apply it at the end. Now, again, what was that figure? Is my calculator still running? It's going to be doing that. It's going to change 262,144 pixels at the moment. So you might think, well, that's going to take a while, but actually it doesn't. It doesn't take any time at all. Let's spin back to over here. If we run this, and there we go. We've got ourselves a yellow texture. Okay, this is obviously horrible. We might want to think about just maybe changing that to white, just to get us started. So let's call this something like, if we just right click here and do refactor extract method. The exam in Studio Effective Office do not yet support C#6. I saw this last time, so let's just use refactoring anyway. And you can say where you want it. So I'll just press up and down to say whereabouts I want it, and I'll put it below the update method. There we go, and we'll call it initialize texture. Shall we? Initialize texture. Press enter. There we go. I like that. I like features like that. And in our start menu now, there's a call to initialize texture. That's good. So we've got ourselves a texture, but now we need to start thinking about grids, don't we? And how we're going to manipulate them. So let's create an array of RD cells. All right, and this is going to be a multi-dimensional array. And the way you do that in C#, which has always caught me out, because if it was Java, I would have done that. But in C#, you just do that, which is saying it's got 2 dimensions because you've got 1 comma there. Alright, I hope that makes sense. If it doesn't, please refer to the C# documentation. It's a shame it doesn't accept both methods like that as well. That would have been absolutely perfect, but there we go. So we'll call this RD cell like that to say it's a multi-dimensional array. So the multi-dimensions are the X and the Y. Alright, if I wasn't making that obvious. So now we'll call it RD cell. That's it, and we'll just call it grid. And I think we'll make that private, because we don't want anybody viewing that. Incidentally, and you probably know this now, but when I look at my plane here, you can see these values of 512 by 512 here. Okay, now if I was to change these values in here now, because I've dragged this into the plane, those are the values it's going to use. This really caught me out for ages. What you can do, of course, if you change the values in here, let's change to 256 by 256, Okay, if I save this, you might think, well, now it's going to make a texture of 256 by 256, but you'd be wrong, because in here they're 512 by 512, and that's the value it uses at runtime. What you can do is say reset, and that will actually go and look at the script there. In fact, I might even keep this at 256 by 256. Excuse me while I have a sip of my tea. There we go. I should probably pause it for moments like that. Oh, it's gone cold. Ugh. So we'll keep it at 256 by 256 for now, which, let's just have a quick look. It's going to be a quarter of that value, I think. 256 times 256. Why doesn't enter work? Enter used to work, I thought. Maybe it... okay, 65,000, which I think, if we times that by 4, I think that'll give us... Yeah, exactly. It's going to be a quarter of the value. That makes sense. So 64,000 odd, isn't it? So that's a lot smaller, and we'll also run a lot more quickly. Okay, so we're doing well. So let's initialize the grid with a whole load of RD cells, and the way you would do that is you do this. You grab those guys, put it in there, and then just do that. And what we'll do is here we'll say grid equals new RD cell, like that, and then we'll say width, comma height. Good. And then what we need to do here is we need to say grid x comma y equals new RD cell. And we don't need to worry about any of the constructors because there isn't one. Alright, and that's just going to create us a grid with divided by 4, 65,536 cells in it. Alright, along an x and a y axis. Incidentally, I'm saying that the x axis is left to right and the y axis is up and down. I'm not 100% sure how this plane has been rotated. I rotated it minus 90, so you might find that's slightly wrong, but it doesn't actually matter as long as we keep consistent. Then if it starts in the top right corner or the bottom left corner, who cares? As long as it doesn't go overflow anywhere and get weird out of bounds, arranged x out of bounds issues, we should be okay. So let's also do that. Let's just call that refactor extract method. We'll call that, and we'll put that below initialize texture, shall we? And we'll call it initialize grid. Beautiful. Okay, our start menu is looking good. And now let's just run it just to make sure it works. This isn't going to do anything, it's just creating a load of cells, but let's just make sure it runs. No errors on the console, just keep your eyes peeled for those things there. Just bring that up a nudge. Just run it. There we go. We don't know that the colour's changed. Let's just change it to... Oh, I think we know that works, don't we? We trust it, don't we? What about colour.cyan or something like that? I should probably be a bit bolder, if you know what I mean. Bolder with my colour choices, but you know, actually create a colour. There we go. So you can see it's working. Happy days. Good. So now we need to get to the meat of it, which is to actually generate a new grid every single time. Now, I suppose one thing we should do as well, let's do that here, is all of these cells are currently set to the default value. Before we forget, let's just add, we'll just say something like grid 100, 100 dot b equals 1f, and let's just do that. We'll create a 2 by 2, right? So we'll do 101, and then on the y we'll do 101, 101, and then 101 there. So we're creating a little 2 by 2 area where b is 1. Okay, and what we'll do actually, let's just do that now. So we'll call it refresh. Let's have another method called refresh texture, and that's going to do a it's going to say it's going to do this. No, it's not going to do that. It's going to do it's going to grab those two. Sorry guys, that one's there and that one there. And then this is going to be a little bit more complicated, and what we're going to do is we're going to say texture dot set pixel x comma y, and the color we're going to set it to, okay, get ready for this, is going to be color dot lerp. Now if you don't know what color dot lerp is, oh, incidentally, by the way, if I wasn't clear, this algorithm, okay, what it'll do is it will change these values to somewhere between 0 and 1. It'll never exceed 1. Alright, and it'll never go below 0. Alright, so actually what you find is that it tends to stick around 0.2ish. Once it's settled down, all of those values are around 0.2. They don't go very high, so we need to adjust the lerp in a second just to make it a little bit more strong. You'll see what I'm talking about shortly. So they'll always be between 0 and 1. Okay, so where 0 is absolutely white and black is and 1 is meant to be absolutely black. All right, so that's what that's meant to indicate. I've got to work out what settings I need for that one. That is a very cool one. Alright, so we're only going to ever get values between 0 and 1 in this algorithm. So what you can do, color.lerp, what it does is it says, well, give me a base color. So we'll say color.white, and give me the color that you want it to go towards. So we'll say color.black, and then give me the value that you want it to be between. Okay, so like I was saying, between 0 and 1, and we'll say here rd cell x, y dot b. That didn't work, did it? Why didn't that work? Sorry, it's not rd cell, it's grid, excuse me, x, y dot b, brackets. Okay, so that's quite a complicated little lerp we've just done there, but what we're saying is the color somewhere between color.blue, color.black, I'm going to go color.blue, and then whatever the value in B is, okay, is what we want that value to be. So hopefully somewhere between white and black, black being 1. All right, now you can see here that this should create a little 2x2 grid of 1s here. So let's, in our update method, we'll call that every time refresh texture. Okay, it's a bit of a beast, but there we go. Refresh texture. And now if we run that, let's just have a little look. Oh, there we go. We'll run this. I don't see that that's worked, because for number 1 this is a blue. Oh, I know why. I know why. Because we have not applied it. Do you remember? So let's do that. So we'll just say texture.apply. If you don't do that, it'll just sit there doing absolutely nothing. So let's try again. There it is, 100.100, and you can see we've got our little zoom in here, 2x2 square. Curiously, looking like it's anti-aliased in some weird way, but that should be a 2x2 square of black. I think that's just Unity having some fun. We're off to a really good start, guys. So that's our grid setup, and we've got some values that we've put in there. Obviously we can tweak this, maybe get a little bit more fancy about how we generate those, but for now, let's just check the frame rate while we're at it. Let's just click that again. Let's have a look at stats. Happy days at the moment, we're getting about 75 frames a second, so that's, you can see it's doing 65,536 iterations, if you like, or you know, updates to the texture every 13 milliseconds. Good news. Alright, but I'm afraid it's time to get busy, and what we're going to do now is create a new method called generate next grid. No, that's in start, excuse me. I want to put that in update, don't I? Alright. Okay, there is no method called generate next grid. Of course there isn't. So let's do that now. Void generate next grid. And we will have the following. We're going to say, well, we'll have RD cell next grid okay, equals new RD cell width comma height. There's a couple of ways we can go about doing this, and I think that I'm going to say I'm going to do the 4int_x like this, just to keep it consistent. I think there might be a slightly quicker way of doing this. It's a bit more efficient on the fly, but let's just see. So then we'll just say next grid x, y equals new RD cell. I think that's right. Okay, so this is generating another grid. Let's just see if that works as expected. Right now, that's just creating the next grid that we're going to use. All right, the next sort of the one that's after this. I can't see it. I'm just looking now. You can see we've already dropped to around about 50 frames a second. Okay, so that was a big chunk, and I think that this is the sort of thing that maybe if there's enough interest, I will have a look and see if we can improve performance, because that was painful. Just make sure I'm still recording. Yes, I am. It would be awful if I'd got this far and I wasn't recording. Thankfully I am. Right, now next grid, RD cell. So we've got our grid created. See, that's annoying to me. I wonder if we could, it might be easier to just keep that as a temporary grid that we'll just reuse over and over. I don't know. We'll see how we'll have a little think about how that's going to work. Okay, but for now that's set. All right, we've got ourselves a grid there. And now what we need to do is do it again. We're going to say do that, and we're going to look at the come on, help me out there. We're going to look at the existing values and we're going to change them. And this is where I need to get my script out. So have a quick look to see what on earth it is I'm doing. Yeah, there we go. It's this one here. What we'll do, okay, remember, so we're spinning back to our algorithm here. We're going to reset A and B, but we're going to put that on the new grid. You can't change the current grid, because if you did that, you'd end up changing cells and then another cell would look at the previous cell. You kind of need to take a snapshot to look at the next grid. A bit like the game of life, how that works. You can't just change them on the fly and keep moving to the next one, otherwise you end up with weird results. You need to sort of look at each cell in isolation and then flow on to the next one. I don't know if that made any sense, but you do need to do that. If you want to try and just update the grid itself, from previous values, then good luck. I don't think that's going to work for you. So what we'll do is we will say let's just get the current values of the cell that we're in. So we'll say float A, current A. No, we'll just call it A. We can say A equals grid x, y dot A. This will just make it a bit easier for us, and let's just do that again. We'll just do B. Okay, that'll just make it this command a little bit easier to understand. And then we're going to need to say something like next grid x, y dot A equals, well, let's just say 0f for now. Okay, and we'll do the same thing here for B. Okay, that's complete nonsense. We'll need to actually get these values based on the current ones plus some little calculations. So let's have another little look at this. Right, you can see this is pretty horrible, but luckily I've managed to break this down. In fact, Daniel Schiffman, I'm going to keep calling him Dennis Schiffman. I apologise. I was trying to give him some kudos, but his name's Daniel Schiffman. He's not going to thank me for that, but anyway, sir, thank you very much. He's actually broken this down a lot more straightforwardly than this guy did here, because I guess he's a scientist and he can understand these things. So let's just type this out and just try and understand how this is going to work. And what we do is we say, okay, it's going to be the current A plus, and then we've got those values dA. Let's get those delayed attribute. So let's get those values in here. Let's just have a quick look at that. Those constants in. So we've got dA, dB, f, and k. All right. So let's go to the top. I guess we'll make those public as well, so we can play with them. Public float dA. Yeah, we'll set them in a second. Public float dB. Public float, don't know, public float f, and public float k. Okay, and if we look at these here, so we want dA to be 1 and dB to be 0.5. Why hasn't that worked? Okay, I don't quite see why that's not worked. Equals 1 f equals 0.5 f. F is 0.055 f, and k equals 0.02. These are, if you like, sort of the salt, the values, and by changing these we can get these effects here later on. But let's just go with the standard for now. Okay, spinning back down to here. So we've got A plus, and then what was it? dA. Times, and what we need to do is he calls it here a Laplacian, and what that means, what they're saying is the cells around it. Okay, so what we'll do is I'll create a thing called plus a. Okay, and we'll just pass it the x and y value. Okay, and what that's going to do is that's going to come back with a number based on the cells around it, and we'll come to that in a second. So don't panic about that. We'll call that in a minute. And then it's minus a times b times b plus brackets f times open brackets 1 minus a brackets brackets brackets. Now have I got that right? Okay, it doesn't like Laplace A, so let's quickly create a method called Laplace A. No, it's not void, it's going to be float. Laplace A brackets int x int y, and we'll just get that to return 1 or something. Now return 1 f. All right, and that's probably going to, there we go. So that's it. So believe it or not, that lot there, you can see there's a's and b's, which is our current ones. We've got our constants f. There's no k there, is there? Is there k? Did I miss k? I think maybe k is used on b only. Okay, let's give that a go. And we'll do it's almost exactly the same for b. So you can see this is kind of all that there really looks a lot more like that. So it's not quite so horrible. It's pretty horrible to if you had to fathom it out yourself. But luckily we've got people in the world like Daniel Schiffman who can do this for us. So it's b plus, again it's open brackets, db times, and let's create one called Laplace b. Brackets x comma y plus a times b, which I thought actually was different, but there we go. And then we've got, now it's minus open brackets k plus f close brackets times b brackets. I'll just put a semicolon, it'll tidy it all up for us, and we'll have to create a Laplace b as well. So let's quickly do that. Alright. Okay, so crikey, that was tough, huh? That was the hardest bit we'll do all day. So what we're actually going to say here is the next grid's a value is going to be this little monkey here. So kind of take what we've got right now, look at the cells around you as well as part of this calculation, and the same for b. Alright, so we're going to come back with that in a minute. We only really care about b when we're actually putting the colours down, but it's sort of a factor, if you like, that adds to it as well. So we can go ahead and we could say now along the lines of grid equals next grid. Okay, I think I ain't gonna. Let's just make that 0.5f just for fun and see what happens. All right. Okay, but these need a lot more work. We just need to go on the cells around them, so that's going to be fine. Okay, so let's Control S and just have a little look. Is that going to work straight away? Well, there's only one way to find out, isn't there? I've just done save, Control S. Let's spin back to Unity and run it. I'm expecting. Okay, it flicks back. I guess this 0.5. Let's just try change this to 0.05 or something like that. Let's just change it to a really low value. I'm just messing around here. See if I can get anything going on this. There, oh, that kind of faded to black, didn't it? All right, so that's okay. That's cool. So we've obviously got some work to do on the cells around us. So I'm just going to copy this in, but let me show you what they're actually saying here. Is what this Laplace needs to do. And apologies if Laplace is a word that you've never heard of before. Don't worry, neither have I. Is it looks at its current cell and multiplies it by -1. Okay, just bear with me. Any cells values next to it. It times them by 0.2, and on the diagonals it times it by 0.05, and that comes back with a value that it passes back to this Laplace thing here, and then that's put into the source. So what I'm going to do is I'm just going to copy this. I've got it over here on here, so I'm literally going to copy this guy. Okay, and just do that. I'm hoping this will work out the box. Nope. Okay, let's just do Control X. Escape that and just try that again. I've had real problems copying and pasting. Control C, Control V. There we go. Good start. Alright, so can you see what we're saying is get the current grid's value, dot A, and times it by -1. Look at the cell to the right, x plus 1, x minus 1, times them by 0.2, so you've got 4 of those, and you've got the 4 diagonals as well that make up the number. And then we'll do the same for you. Control C. I think what I have to do is I have to do Control X here. This is what I have to do. I think I have to do Control X and then Escape. Go back into here, Control C. I'm pretty sure this is MonoDevelop's fault because Control V isn't always working. There we go. Now we're saying, look at the B values. It's exactly the same, but I'm just kind of breaking A and B down because I need to look at the values around it. If you want to see if you can make this one function, good luck. The Laplace function, please be my guest. Alright, so it's looking at the cells around it and it's coming back with a value based on the cells around it and its current cell. Alright, and so what we're going to end up with is these sort of cells that are just going to sort of generate change slightly depending on what they are now and what the cells are around them. So let's give that a go. Let's go Control S, Shift Control S in fact, and we'll run it. You can see, where are you? There you are. And I think this is going to fail. It's going to throw an index out of bounds. There we go. And the reason for that, it's throwing a lot of them, is because this here is got x minus 1, and if we starting the grid at 0, 0, x minus 1 is going to be minus 1. So an array can't have a negative value. What we should do is get it to go, if it's minus 1, then get it to go to the right hand side. And I think we should do that, but we're not going to do it just yet. And so for simplicity, I'm just going to do 1 there and 1 there, and I'll say width minus 1 so that the plus 1 doesn't go too far as well. Height minus 1. Okay, and that should work a lot better. Right, let's give this a go, guys. This has been Can you see what's happening here? It's actually working rather well. Now, the first thing that's kind of obvious to me is, like I mentioned, is that it's a little bit. It's not really black, is it? It's kind of a bit grey. Let's have a quick look at the stats as well. See what frame rate we're getting. We're getting 40. No, we're not. We're getting 25 frames a second. And you might think now that it's actually stopped, but it hasn't. It's just gently expanding. In fact, what might even be better is if I actually make this even smaller, just to make it really clear what's going on. So a couple of things we can do. Before we run it again, let's go into here, and where this color.lerp is, we'll just make this .b. Let's just try times 3f. Okay. The good thing about color.lerp is if you go above 1, it will just set it to black, so you don't have to panic about this. It's not going to blow up and say you've exceeded 1. If it's 1.5, it'll just say I'll set it to black. All right? So you don't have to worry too much about that. But you might end up with a very... There we go. So that's blacker. That's good news. And you can see, I don't know if you can see, but the cells around it are just slightly lighter. Let's make this bigger, so you can see what's going on. Alright, and we can see this is going away. So let's make this run a bit more quickly by going back over here, and let's just do, we don't have to have it as 256 by 256, let's just do 128 by 128. That's very small. Oh, cancel that, but it should be nice and quick. Yeah, it doesn't look great, does it? But we're going to see the effects that we want to see. Alright, we're going to see this expanding now. What frame rate are we getting now? There you go, 75 frames a second. And you can see that by using this algorithm, all of a sudden we've got this rather attractive looking effect that's taking place. It's almost organic, isn't it? And you're thinking, well, okay, well, I can see what's going on here. This is symmetrical, and you'd be half right. Let's just follow this through and just keep watching it and see what happens. I might even speed this bit up. Do you know what? I'm not going to speed it up. I'm just going to talk to you what's going on. It's very hypnotic, I find. See, this is a new effect. I've never done a grid this small before, and now it's created something new and rather bizarre because it's hit the corner so quickly. You can see what happens when it's hit the corner. It's kind of got this big black blob, and we can avoid that if we want to by using a sort of a wraparound. So rather, if x minus 1 is minus 1, then set it to the right hand side, and the same for plus 1, set it to the left hand side, and so on, and top and bottom. Here we go. We're getting close. So I'm hoping that this won't be symmetrical because well, if on larger grids it isn't, as you might have seen at the start. But this one is looking very symmetrical now. What tends to happen is it starts symmetrical and then it'll hit a certain point and then it'll stop. So let's just find out if that happens. I think maybe some of that's to do with the fact that these floating point variables are very, are probably a little bit floating points are a little bit variable in computers. But right now this is looking very much like it's symmetrical, isn't it? Sort of diagonally symmetrical. We're nearly there. I'll tell you what I'll do. I'll pause this and I'll come back when it's finished. 1 second. Well, can you believe it? Sure enough, that was symmetrical. And a couple of things I think that might have caused that is one is that it's a very small grid, and also I had them in a very specific point. So what I think I might try is adding a couple more places to it. So just where's that? There it is. There. So let's just do that in a couple of other places. I'm just going to pick a. Let's just do, I don't know. I'm just guessing 50, 51 and 50, 51, and we'll do the same again. 50 and 51, and let's do 60, 60, 60, and 61, 61. Right. I don't know what that's going to be like. Let's give it a go. See, so now we've got a lot more. We've sort of thrown some black dots on there, and let's just have a look, see how that looks now. 1 second. Let's run this. Am I recording? Excuse me if I'm paranoid about this, but I had a situation where, here we go. This is a bit more interesting, isn't it? Yeah, I had a situation where I did a whole thing and I wasn't actually recording. I did one once when I was recording on the webcam, which wasn't terrible, but it had a real sort of echo to it that was annoying. Right, this is looking a lot more fun, isn't it? Like I say, I'd encourage you to change these widths and heights, and be a bit more patient. Hope maybe you've even got a faster computer than me, in which case you might be able to see some improvements in speed. In fact, I can already show you one way to improve speed now. It's kind of weird, isn't it? It's like what do they call those things? Ink blot tests. You know what I'm talking about? So any second, I'm hoping that this will start to, rather annoyingly, I think they're not going to touch each other. I was hoping they'd bump into each other at some point, but they're not. Bump into each other. Yeah, now this is not symmetrical. You can see that now. This is a lot more weird. And certainly, if you pick a larger grid and perhaps a few more locations to put the sort, it'll start to get a little bit out of control, and there'll be no. Now you can see it's a lot more random, isn't it? There's no clarity on where this is going to go. All that from just a few numbers. I'm going to let it finish this time. It's almost a maze, isn't it? In fact, well, if there's enough likes on this, guys, I'm going to try and turn this into a maze. Let me just quickly show you one way to optimize it, and that is we don't need to run this refresh texture every single time. So what we could potentially do up here is have a public float refresh rate. Okay, and we'll just set it to, let's try half a second. So we'll say is equals 0.05f, and we'll say private float, and that's going to be time of last. No, next refresh time. Next refresh time. Semicolon, and what we'll do here is we'll say next refresh time equals time.time plus refresh rate. Okay, and down here I think we'll say if brackets time.time is greater than next refresh time, and then what we need to do here is we say same again like that. Okay, so that's what we're doing here is we're saying don't run this refresh texture every single frame. You don't need to. It's going to look a bit more clunky when we do it like this, but over a larger grid that's absolutely fine. So let's just, so what were we getting before? We were getting That's a good point. We should probably check what we got before, shouldn't we? So let's just switch those off. So we're still going to run it, regardless of any time things there. We'll just keep going, and let's just run it and see. Okay, stats, we're getting a rather healthy 75. So let's just up that. Let's just up the frame. Let's just put it back to 256 by 256. Okay, and then we'll run it again. Okay, we're getting 34 frames per second. 30, what's going down? Okay, 30-ish frames a second. Okay, that's not too bad actually. But if we run it with our new don't refresh every time scenario, Shift Control S, make sure you save it, otherwise you get confusing results. So it was 30 frames a second-ish, wasn't it, before? Let's have a look now. Well, curious. Oh no, hang on. No, there we go. So we're getting 45 frames a second. Look at that. That's such a difference. So you can see that refreshing this thing is slow. So we don't need to refresh it every frame because we just you know, you can see that the changes aren't that great. But although, you know, I'm not hugely happy with the it looks a little clunky. Maybe we should go for 0.25, but I'll let you decide. So guys, that's it. Of course I will put links to the GitHub location of this project for you to enjoy and have a good play around with. I'll also put some examples of other values, of the F's and K's, just to see what happens. In fact, have we got time? Should we just try one? You can see this is creating an interesting effect already. But once it touches the corners, things start to get a bit annoying. But when you actually, you know, when you put things in the middle, they can create those weird effects. Is it just me, or are they avoiding each other? They've kind of squished up. Very interesting. You can see that there's little lighter colours there. I don't know. It's a very weird looking effect. I like it already though. I like where this one's going. So have a play around, but have some fun with this. And if there's not, if there's enough interest, I will do a 3D model of this. They're definitely avoiding each other, aren't they? These ones can't. Look, they can't. They seem to be heading towards each other in a corner. As do they. That's weird. I'll let you decide how you think this thing actually works. But this is a really interesting one. I like that. So let's just try changing F and K. There was a suggestion. Hang on this page here. Somewhere. Coral. So here are two videos that shows mitosis, that one, and coral growth. Well, coral growth is what I thought we had. Hang on. Excuse me. Yeah, here. 0.545. Well, he's gone 5.5. It's not the difference, is it? What's this one? Mitosis. Let's try this. Let's try that. 0.0367 and 0.0649. Okay. So where's our script? Here. So F was, sorry guys, F was 0.367. What I might actually do is just do that, and then, whoa, it's done that thing, 0.0367. Okay, and the other one, K, is 0.0649. Let's make that F. 0.0649 F semicolon. Yeah, I don't know if you don't always have. Oh, what are you doing over there? Semicolon. That's why I didn't put a semicolon. There we go. Okay, not a lot of difference. Let's see how that looks. Okay. Well, I can't see much difference yet. Let me pause this and let's just see how. Well, let's just follow it through. It's doing a nice circle. So what I will do, I think, is I will put some suggestions in there to set these values, and then you guys can have a play and see. Well, this is interesting already. It's not quite the same, is it? It's definitely doing something different. Definitely different to the preview. Well, I say definitely different. Maybe not. Don't know. It's hypnotic and mysterious. I'm not gonna make you sit through this and watch. I will. I'll let you have a play around with it and do it yourself. I will maybe put another video out with some different results if you wish. Alright, all the best, guys. Thank you for watching this. I hope this has been helpful. I really appreciate the comments, the likes, and the subscribes I love. Obviously, I love them all. I love everything. I hope that I'm giving you you guys some good advice. Please let me know what you think. Do you want me to continue down this road? Should we do another one? Should we do a 3D one? I look forward to hearing from you. All the best. Speak soon. Cheers now. Bye bye.